Let's take a look at a typical problem we might see in our section dealing with sine and cosine graphs. We have a Ferris wheel that is 25 meters in diameter and is boarded from a platform that is 2 meters above the ground. The 6 o'clock position on the Ferris wheel is level with the loading platform, and the wheel completes one full revolution in 10 minutes. The function h equals f of t gives your height in meters above the ground after the wheel begins to turn. And we want to write an equation for h equals f of t. We want to find an equation for this curve. So let's start by drawing a picture of the Ferris wheel. And we'll add in some coordinate system here. We'll put the origin down here at ground level. And I know the loading platform. So we're going to start our journey here at t equals 0. Our height would be 2 meters above the ground. We know that the diameter of the Ferris wheel is 25 centimeters. So this top edge would be 27 meters in the air. And as we travel around this, we do one revolution every 10 minutes. I'm going to assume that we move counterclockwise just because. So if I go to this point out here, take it a 90-degree angle off of the vertical axis, and I want to know, well, what is that time? Well, we've gone a fourth of the way around the circle, so we're going to go 1/4 of those 10 minutes. It's going to take us 2.5 minutes to get there, and our height above the ground would be a total. I know that the total height of the Ferris wheel is 12 or is 25. So the height would be I've got the 12.5 feet from the center of the Ferris wheel to the loading platform plus the 2 feet there. So the height would be 14.2 or 14.5 meters. At the top of the thing, that's another nice point to look at. That is 5 minutes into our journey around the Ferris wheel, and the height above the ground would be 27 meters. Another point to come across that's fairly easy to come across is this left point over here. We can argue that we're 3/4 of the way through that, so we're at 7.5 minutes, and our height will also be 14.5. And then at t equals 10, we're back down here at the bottom where h is equal to 2. And if we go around again, I'll be here at 12.5 minutes. I'll be back at the 14.5 feet. So now let's sketch that out, sort of the longitudinal curve, t versus h. Let's take those values and sketch them out. I know that at t equals 0, I'm starting at a value of 2. And then at let's call this 2.5. I know that the height I'm going to be is 14.5 meters off the ground. And then at 5 minutes, I will reach the maximum height of 27. And then at 7.5 minutes, I'll be back to 14.5. And at the 10-minute mark, I'll be at the 2-minute mark. And then if we keep going around at another 2.5 minutes, I'll be back to the 14.5. Add another 2.5 minutes. By the way, that's a very slow Ferris wheel, but I guess 25 meters is pretty large. So anyway, so let's connect the dots here, and we get a nice sort of sinusoidal curve there. We'll get a nice sort of sine curve going on to that. And we need to find the equation basically for that sine curve. We want to know what the height is as a function of time. The midline of our curve turns out to be this 14.5. Well, let's maybe decide what type of curve I want to use. I could use a sine curve or a cosine. I'm going to choose a cosine function because I think that's the easier one to do. The cosine function normally starts at a maximum. Our curve here is starting at a minimum, and I don't have to deal with any sort of shift if I use a negative amplitude. So if I do negative the amplitude, well, the amplitude is 12.5. If you look at the distance from that midline to the top, or from 2 to 14.5, that is 12.5 for our amplitude of our graph. And we'll do a cosine function, so I don't have to deal with any sort of shift there. The period that we have is going to take a horizontal distance from valley to valley or from peak to peak. It's 10 minutes for the period. And I know that 2 pi divided by b will equal the period. So I know that 2 pi divided by b is equal to 10. So 2 pi equals 10b, and b would equal 2 pi divided by 10, pi over 5. So I'm going to look at pi over 5 times t. For the inside, I don't have any sort of horizontal shift. And then I need my midline. I need to add the plus d value. The midline would be the 14.5. And that equation should give us the curve that we're looking at, should produce that graph that we're looking for there. Just to do it, that's probably good enough. But if we wanted to use a sine curve instead, the sine curve, a lot of the values are going to stay exactly the same. Whoops, I wrote sine, but I really mean cosine. I really wrote cosine, but I really mean sine here. There we go. I want sine. The amplitude is going to stay the same if I'm looking at this as a sine curve. The only difference is I have to do a horizontal shift. And the sine curve, the regular basic sine curve, starts at 0 where it's crossing the midline and going up. So this is kind of a corresponding spot on the graph of the graph that I'm working with that corresponds to 0 on the graph of the curve that I'm looking for. And so what I'm going to do is I'm going to take that. Yeah, I'm going to have I'm going to have a bx plus c inside the curve. I'm going to take that bx plus c, or bt in this case, plus c, and I'm going to use that value in there to find that shift. And so what I want to do, I've already found b as pi over 5 based on the period. I'm going to take this x value here of 2.5, and plus c, I want to know, because that corresponds to the normal location of 0 on the graph. And so what I want to do is say, what value for c do I have to have to get that to shift over like that. So I'm going to have pi over 5. I'm going to change 2.5 to 5/2 because the numbers work out better. Plus c equals 0. I can cancel the 5's involved, and then to solve for c, I get c is equal to minus pi over 2. And so I want a minus pi over 2 in there for my c value. So the equation would look like y equals 12.5 sine of pi over 5 times t minus pi over 2 plus the 14.5. So for the sine curve, the amplitude stays the same, the period stays the same. The only difference between the sine and the cosine is I have to deal with a shift there. I have to do with a horizontal shift of, in this case. And I move in the positive direction, and I end up with a minus inside here, which should be consistent with what we've learned about values. Okay, I hope this helps you solve these problems.